Greetings, and thank you for joining us for another SANS ICS Concept Overview. I'm Don C. Weber of Cutaway Security and a certified SANS instructor. In this concept overview, we are joined by Virginia Wright of Idaho National Labs. Ginger joins us to provide an introduction into Cyber-Informed Engineering, or CIE. We discuss the role CIE plays in helping organizations identify and limit risk within their control environments. We talk about where you can find resources, training, and we also touch on the difference between CIE and consequence-driven cyber-informed engineering. If you enjoy this video and the topics we cover in the SANS ICS concept overviews, be sure to like and subscribe to this channel. Leave a comment if you have a question about this topic or suggestions for future content. Okay, welcome back everybody to another SANS ICS concept video. This time we're joined by Ginger Wright. She's a program manager out at Idaho National Labs, INL for some of you that call it INL. But I've asked her here today to talk about a topic, and one of the things that one of her programs that she's working with is cyber-informed engineering. So as soon as I found that out, I knew that y'all are probably going to want to hear about this. I'm certainly interested in it. So Ginger, why don't you go ahead and introduce yourself, your background, so people know, and your role at Idaho National Labs, and then we can certainly, whenever you're ready, get into CIE, cyber-informed engineering. So go ahead and take it away.
All right. Thank you, Don. So I have been at the Idaho National Laboratory for 17 years. I moved from the DC metro area. I was working for a government organization, and a friend of mine who had retired to Idaho came back to visit us in Chantilly, Virginia, and said, "Hey, have you ever thought of moving to Idaho?" No, Randy, no one's ever thought of moving to Idaho. But he brought us out. It was July. There was zero humidity. He would slip housing circulars under the door with, you could have, 10 acres and all of this property. And pretty soon we were thinking about moving to Idaho. At the Idaho National Laboratory, I have been able to manage cybersecurity critical infrastructure projects that range from interdependency analysis. If anyone has heard about Citrix, cyber testing for resilient industrial control systems, that's a program that we founded out of a lab-funded research and development effort. If you can imagine, we got $50K to start experimenting with what would happen if we could look into the hardware and software of control systems. Would we find anything interesting? And that has then turned into a 6-lab, multi-million-dollar program that we are so proud of, with vendors and labs all collaborating for hardware and software transparency. And after Citrix, I've turned my attention to cyber-informed engineering. I am the daughter of an engineer and the sister of an engineer, so you can imagine what family dinner was like. I focused in information technology, but I never forgot those engineering roots, and especially the importance that my father and brother placed on the idea that an engineer is the ultimate risk manager for anything that they are involved with. That whatever it is, left, right, sideways, up, down, whether it is the physical layer, whether it is the digital layer, it is the engineer who should be empowered to make decisions about risk. But what I started to see as we went on assessments, as I worked through Citrix, is that often with digital equipment, with cybersecurity, the engineer was wholly delegating that responsibility out to the cyber team because there wasn't a great language to get the two talking together. And so with help from some of Mike Asante's great work, with help from other folks at the laboratory, we started thinking about what would it look like? What would we need to do to bring the engineer back into being the central decision maker for cybersecurity? How could we get them to think about digital risk from the very beginning of a design endeavor, before they've even selected what technology they're going to use? Thinking about what consequences a failure of digital technology or an attack on digital technology could have, and how they might engineer fail-safes into the system. And we're not doing away with the traditional cybersecurity protections that we put on systems now. That comes later in the life cycle, but informed by and tailored to the consequences that are most important for the process that is being engineered, the system that is around that process, and the institution that ultimately owns the whole thing. So because no presentation from a laboratory is complete without slides, I brought a few. So if you don't mind, I'll go through those just to illustrate a little bit more about cyber-informed engineering. And if you see a pair of ears peeking up from where I'm sitting, my cat Rosabelle has joined us. She loves being part of any presentation. So she's very glad to join us today too. Okay, let's see. With cyber-informed engineering, again, we are trying to put the engineer in the middle of the cybersecurity process for industrial control systems. INL started this work directed by Congress in 2020. And we brought together a dream team of thinkers from asset owners, from vendors, from universities, from laboratories, and we started thinking about and talking about what would cyber-informed engineering need in order to become a way of doing business. How could we bring this about, and what does it mean? So we created a national cyber-informed engineering strategy, and I'll put a link to that in the show notes for this. And in it, we defined the high level of what the cyber-informed engineering principles are, and a set of integrated pillars through which we could implement cyber-informed engineering. With each pillar, the dream team gave us some recommendations that are guiding our work right now, so that we can take this idea from something that we discuss in teleconferences to something that is usable by industry, something that is taught in universities, and that we can put it in front of people with tools and capabilities to make use of it. Since creating the strategy, we have been developing working groups and going a little bit deeper into what cyber-informed engineering is. And I'd like to talk to you about a few of the things that we have going on in that area, and most importantly, how you can get involved in forming these ideas. So I will say we are just writing the book for cyber-informed engineering. We're not finished yet, and there is a lot of opportunity for people. So if anything that I talk about here sounds interesting, do email us at cie@inl.gov. First, our advisory group suggested in the 5 pillars that we first needed to make everyone aware of what cyber-informed engineering is, and find a way to make sure that we were spreading the word about that. They then suggested that after some university soul searching, this is not taught in engineering curricula today. So if I have somebody at a university getting trained in becoming an engineer, they are not taught about how to manage, using engineering solutions, the failures that can come from digital equipment. Again, either if it fails naturally or if it is attacked. And they are not taught how they can engineer solutions to that. So one of our pillars is to work with universities and build a curriculum that incorporates these ideas. Universities are pretty parochial about their engineering curriculum. They don't want to add courses. They don't want to do more than they already have, because for many universities, these are very packed 5-year endeavors. So our education working group has to be very smart about where they can put in labs or certificates or contests or assignments that bring these ideas. So we're not only designing courses, we're also designing things like capstone exercises that can bring these ideas out for students. Because no engineer is complete without the modern equivalent of a slide rule, we know that we need to develop tools so that people leveraging these ideas don't have just a philosophy. They have a way of measuring different trade-offs, because engineering is all about trading off of risk. They have ways of saying, if these are the physical changes I can make to my process, and these are the cybersecurity protections I can put in place, what's the ideal mix of those that would provide the right consequence or the right protection for the consequences that we imagine? How often should I monitor? How can my monitoring be tailored to the actual consequences that I care about, as well as the normal hygienic work that needs to be done? So in the development area right now, we are creating CIE implementation guidance. What are those questions that we think about if we're in a design process that let us apply cyber-informed engineering? But eventually we're looking to create tools to show how cost-effective this method of design is. How can we prove that our systems are more protected against cyber events if we design security in, especially with a consequence-focused view, rather than waiting until the end and allowing our cybersecurity team to wrap it in the right digital protections. So around these pillars and a few application pillars, we have developed some working groups. We have a community of practice that meets quarterly, and that group hears about the things that we're doing to bring about cyber-informed engineering, and they get to advise us. But from that group, we've stemmed out 3 working groups that meet monthly. And these are the groups that are rolling up their sleeves and contributing to our implementation guide, our educational curriculum, and very soon in August, we will start looking at standards. For the standards that we are working with now, whether you're using 62443 or something else that guides how you design systems, are there places where cyber-informed engineering could be inserted? We don't need another standard, but making sure that we're bringing these ideas into the standards that exist is a great endeavor for us. And those are all the different things those working groups can do. We welcome the public in those working groups, and anyone can be part of it.
Since you brought up 62443 and you're talking about the frameworks and standards and stuff like that, is it more of ensuring that the standards have a matrix to align so that it can demonstrate where it applies, or are you not even there yet?
It is partly making sure the standards have a matrix to align, but also what we found in our FAST survey of standards is that we have a pile of engineering standards, and we use those to build systems and design things. We also have a pile of cybersecurity standards like cybersecurity framework, but those standards right now aren't built to have the 2 groups talk to one another. There's not a cutout in the standard that says, hey, if you're dealing with an engineered system, you may want to talk to those that designed the system about the consequences it could experience and tailor your protections to those consequences. You may want to bring them into the conversations as you're designing the secure network approach to make sure that you're capturing the key data elements and putting the right protections on those. So part of our work is going to be, and my mental picture with this is if you picture a pair of Converse tennis shoes and you have the placket with the grommets down each side, we need the shoelace that pulls those plackets together so that our standards enforce the idea that engineering teams and cybersecurity teams operating in a vacuum does not provide us the security impact that those teams collaborating together could have.
Yeah, and that's one of the things that I'm looking, because I'm going through the 62443 training. I'm almost done, and you know, one of the things that I see in the standard right now is there's it is generic input about how to measure a consequence, how to measure likelihood, and so forth, and really looking to allowing the organization to select their own path, and just really saying that they should be doing those things. And certainly, so this is one way, because I've been trying to figure out, like, okay, how am I going to assist when I'm talking about consequence and so forth? So this sounds like a good starting point, or at least from an engineering standpoint. I'll have to look into it to see how it can help me understand it from the InfoSec side.
Well, and specific to 62443, this is very preliminary, but one other place that we hope to be involved is in the application profiles that some of the working groups are starting to build out. If we can bring cyber-informed engineering into those, that may provide a better hands-on picture of how to apply these ideas, again, in engineering design. But I do like working with 62443 because it encompasses some roles around cybersecurity that I see other agencies simplifying. So we have original equipment manufacturers who create equipment, and their job is to secure it to the needs that they understand and to the customer interests that they understand. But that equipment is deployed into lots of different environments. For one customer, this device may be the keys to the kingdom. For another customer, it's a no, never mind asset. So the idea that there is one security approach for an original equipment manufacturer, we're far more nuanced than that. We then have system integrators, and they often create solution packages. Those too will assemble lots of different equipment with lots of different security assumptions. And finally, we have asset owners who have their own security context to wrap around this whole. I like 62443 because it gives each of those roles a set of responsibilities and a way of talking to the other party in the system. So back to cyber-informed engineering, one really interesting thing that we have coming up, NERC released very recently a document on cyber-informed transmission planning. And when we think about transmission planning, this is, very far out planning for where we might build substations in the future, where we might need equipment. And we have some traditional mechanisms to do that kind of planning, thinking about where we might need to build up resilience. But a lot of that did not include the idea of cyber failure. And so NERC offered some guidance to transmission planners about how to become cyber informed in thinking about what the failure modes could be and how to perform transmission planning with that in mind. So we are joining with NERC. INL will present on cyber-informed engineering. NERC will talk about cyber-informed transmission planning, and EISAC will also be there to talk about their information sharing capabilities and how they can help with cyber-informed planning. So I'm excited about that webinar. It's coming up on July 10th, and it will provide a great way of making cyber-informed engineering real in a real practice that is performed by industry. Transmission planning was not the first place I thought we would start, but it is certainly an excellent place to begin thinking about what are the impacts and the consequences of cyber failure. Also, for those that are interested, we have a practitioners workshop coming up on September 6th. This is open to the public. Anybody can be part of this. We're assembling a number of talks on cyber-informed engineering and how to perform cyber-informed engineering. It will range from how to attract executives into letting you start this planning process, how cyber-informed engineering can factor into an engineering standard of care. And at the very end, we will release our cyber-informed engineering implementation guide and have practitioners go through that and give us feedback on it. So if you are interested, join us at the practitioners workshop. So I think that's it for the slides I have. Don, what questions do you have? How can I talk to your audience more about this?
It's an excellent start. Certainly this seems like a very strategic effort, meaning that this is something that is designed for an organization to understand themselves, certainly calling out specific areas, not doing possibly doing a large area at once, but often drilling down into specific areas. So would that be more accurate?
That is accurate. And when we go over our 12 principles, and I won't do that today, but I see audiences and they glaze over and they think, oh my gosh, this sounds so hard and it just never ends. But the most important principle is our first principle, and it is consequence-focused design. So we do apply a great deal of rigor, but guided by the consequences that are most meaningful for an organization. Certainly for the things that are recoverable consequences, maybe the cyber hygiene that is in place is sufficient. But for those consequences that are existential, that could be the end of a business, could be an extreme safety impact to employees, those are the things that we want to ensure they can never happen. And that's where leveraging cyber-informed engineering is helpful. So not all projects will use the same amount of it or the same set of rigor. It all is about what consequences that process could experience if there was a cyber attack or digital failure.
So is this kind of taking over the business impact analysis from a cyber standpoint? Is it replacing that?
I'm not going to say it's replacing it, but it may be a new way to think about it. And it may be a way to guide yourself through that is different.
Interesting. So how long does that, obviously the 12 steps, it seems really long. So what is the length then?
So right now, this is a philosophy. This is a way of thinking. So it is guided by the design team and what rigor they choose to use. We're hoping that this gets built into curricula so that we can start to understand and make some recommendations about how much to use, maybe even some design patterns. Since I come from an IT background, that's a very familiar thing for me, but maybe creating a design pattern that if it's this sort of a system with this risk profile, here is how you might apply cyber-informed engineering. I think that's in our future, but we're not there yet. There is another INL capability called consequence-driven cyber-informed engineering. And that is a methodology that is a how process. They go step by step through an engineering process, looking at the most impactful consequences, the equipment that is tied to those consequences, any frailties in that equipment or places where digital technology could be attacked or fail, and then recommends protections that could be put in place, alternate engineering approaches, fixes, or places where more monitoring needs to be done. So if you're looking for something that you can absolutely apply as a turnkey approach, that's that consequence-driven cyber-informed engineering. If you want something to help engineers think differently about the design process and start to think about cyber risk from the beginning and own that piece of the risk envelope, that is really CIE.
Okay, yeah, and so it makes sense to me that you're one of your initial efforts is trying to get into the education because people are doing for the brownfields. They're actually implementing right now. It's already in place. They're already moving forward. Certainly, they might have times during maintenance periods or reevaluations for upgrades and stuff like that. But even that's not going to change very much. But getting those people that are going to be designing new things, getting this into their education is going to probably be the quickest way to get implementation into the field. So that makes a lot of sense to me. Going back to the greenfield brownfield thing is, and that's kind of my question is for the brownfields, is it more likely that they're going to look to that consequence-driven cyber-informed engineering? They're going to have a little bit more valuable results from that process for the brownfields?
So either one can be leveraged in a brownfield situation. If you come and you're doing a small patch or a small upgrade in an existing system, you can certainly leverage cyber-informed engineering to think about what protections should be put in place. Otherwise, if you have the opportunity to create an upgrade and you want to look deeply and assess where protections could be added that would be most meaningful, CCE might give you the fastest way to get that answer. We get a lot of folks who like to break these apart with, okay, CIE is greenfield, CCE is brownfield, and they fit together so well. CIE certainly has more potential to create opportunities in a greenfield analysis, but it works in brownfield. CCE gives you more opportunities in a brownfield, but you can do it for greenfield as well. Our CCE team does look at projects that are just in the design phase, and they still can do the assessments that they do because you know that you're going to use a turbine. Okay, let's explore how that turbine's going to be used, what it's hooked to, so they can still do the system of systems analysis, even if all they have is documentation.
Yeah, it sounds to me like the cyber-informed engineering is a tool that can be used during risk assessment processes, specifically for the brownfield areas. And then as you're getting into the implementation, we've identified these things, how are we going to approach that, the CCE? And to me, this is kind of like when I'm looking at security programs, I want to use the NIST cybersecurity framework to understand what's currently implemented, meaning the maturity of their program. But when I wanted to get into specificity around what should actually be done to improve those programs, looking to 62443 for some of that more granular inputs. So it sounds like this would be leveraged in a similar manner. Cyber-informed engineering for some of that understanding the maturity, our approach to positively affecting the digital implementation within our environments, but then that specificity around exactly what we want to do, organizing that associated with consequence driven choices, then the CCE might help there a little bit better. Would
Sure.
that be accurate?
CIE is kind of do it right. And then CCE is how did we do?
Okay. Nice, nice. Okay. That's really all of my questions. And one of the things I kind of scrolled the banner across. I don't know. That was the first time I've ever done this, but that's accurate. And actually, when we throw this up, I'm not going to scroll through here, but you can see this is the website. This is the place that people should go for a little bit more information and to find some of the resources you talked about. Is that correct?
That's correct. And at the end of the year, we will open an open source library on this page where we will have curated the CIE documentation that is available from the Department of Energy. And we also welcome if there are users of cyber-informed engineering who have created case studies. We would love to hear from you and put your slides and information in that open source library as well. We would like to build a set of tools that everyone can use to create cyber-informed training, cyber-informed engineering education, and to use it in real projects.
And that kind of brings us back around to one of my first questions before we started this. And I don't know how much you can talk about this. Obviously, there's, considerations around NDAs and so forth. But can you give a description of something that might have been successful, somebody that was implementing this, whether it's just kind of a sector reference or some type of condition that improved because of that organization implementing this?
Sure. So the example I'm going to give you is a CCE example, but it could have been a CIE if we'd had more materials available. There was a microreactor project because here at the laboratory, we absolutely eat our own dog food or drink our own champagne. Maybe I should go with Jen Easterly's preference. But we applied cyber-informed engineering. This was a project that was being competed. So multiple teams came in, they took CCE education, they learned about the cyber-informed engineering principles, and they had an opportunity to apply those ideas to their own design. That was assessed as a part of the competitive package, and one of the best implementers was voted to go forward. And that designer then came back and met with the CCE team directly and involved them into the microreactor design process. They came back and were extremely surprised because they came into that process like any confident, mature designer, I'm not going to learn anything. This isn't going to change anything I do. And they made changes to their design based on what they learned in the CCE education. So they did apply cyber-informed engineering principles to ensure that the microreactor was less susceptible to digital failure.
Excellent. I really appreciate that. So are there any last minute thoughts, and how can people reach out to you besides the website? Is there any other ways to get a hold of you?
So the best way is the email address cie@inl.gov. Anything that you'd like to participate in, whether it's the community of practice or a working group, we would love to have you take part. It's always exciting to have more enthusiasts. So that's number one. If you'd like to be registered or find out more about our practitioner workshop on September 6th, that same email address, cie@inl.gov, let us know that you're interested and we'll make sure that you're registered and can take part.
Excellent. Well, Ginger, I really appreciate you coming on here, letting us know about this. I think it's important. I hear a lot of people talking about this. And certainly the fact that we're educating our engineers and our information security professionals, especially those that are going to be moving towards leadership around this, I think it's important to the people that I respect and understand that kind of drive some of these things in the community, actual implementation, are already looking to this for their future projects. So I appreciate you taking the opportunity and coming out and letting us know about it and where to find out more. So
thank you so much. I look forward to hearing from the audience and teaching you a little bit more about cyber-informed engineering.
Excellent. Well, thank you, Mary, for joining us, everybody. And
thank you.
Until next time, bye. Thank you for tuning in to another concept overview with the SANS ICS and Cutaway security teams. Please let us know if there are other topics you would like us to cover in the comments below. If you enjoyed the content, please be sure to like and subscribe to the SANS ICS YouTube channel. This has been Don C. Weber of Cutaway Security. Go forth and do good things.